Hi there, this is Alex Kiri from learn.alexkiri.com. In this video, I want to continue the topic on the previous video I shown on building Linux development environments on Windows as code using WSL2 and Docker. And one of the reasons I find this topic quite interesting is that it happened to me many times when I was, as a developer, when I was joining a team, that in the first days, weeks, or maybe months even, I would still be working on setting up my initial environment. And that really depended on basically all kind of pieces of documentation, sometimes outdated, and just simply learning as I go from my other colleagues, what kind of tools they were using, what kind of tricks, and so on. And I always thought that it would be very much nicer if all of this would be done in a different way, namely as code, since the same way we build pipelines or infrastructure and so on. And with Windows Subsystem for Linux, I find that there are a lot of pieces that fall in place and that enable much better such a process. And there are many things I would like to improve on this approach. So it's still quite a proof of concept, of course, but it really relies on the very simple idea that you can export the user space of a Docker container as a tar file and import it into Windows Subsystem for Linux as a distribution there, and then benefiting from all the integration it has with the operating system. In this video, I'll show you a work in progress approach on how to manage these development environments and then update them locally. Right now, it's still quite focused as on my use case, where I'm just one person, maybe having one or two computers, and it's still a proof concept. But I will mention at the end what changes I would make to this flow so it better applies into a team of developers. But let's talk about that a little bit later. Right. So this is the same repository I showed you, or the same project I showed you the last time, which includes different Docker files, one per environment or one per, each of these can later on be imported as a WSL distribution. And some of them would depend on each other. So basically the first one is basic. This one starts from Ubuntu 18. And I install in it all kind of basic tools that I find useful for my development work, and I configure with my Git username and email and my Z shell and my preferences and so on. On top of this image, there are others. For example, Docker, the Kubernetes Docker file depends on basic, and then there is the Azure Docker file that depends on the Kubernetes one. So there's all kind of dependencies. The idea being to just have images for specific purposes and so on, and you can extend from here as you need. Also, the idea is that you don't want to have this huge stuffed image with everything, because then you end up exactly where you started from. So the idea is to have like more purposed, focused images for different purposes. And in the previous video, I showed that the way I build these images is through scripts. So I have here a parent script that basically triggers a rebuild for all of these images here, and also it creates a container and it exports them as tar. So they're ready to be imported into Windows Subsystem for Linux. And this flow is quite nice if you have just one computer or just one user. All the tar files stay locally here, and the images are local, so initially I didn't push them anywhere. But then I wanted to be able to get and use these images on a secondary computer. So then I needed to find a different flow for this. Plus, I find that it's pretty time consuming to run this parent script. It takes quite a while to build these images. And when I make small changes, maybe not all the images have to be rebuilt. Of course, I could just manually go and rebuild the images that I think that would be affected, but still, it wouldn't be something that I would just fire and forget. And this is around the time when I found out about ACR Tasks. So Azure Container Registry has a feature called Tasks, which they're basically some very basic pipelines that allow you to build and publish Docker images. And this Azure Tasks, they can get triggered from commits to repositories. And this is why I decided later on, after I played a bit with them, to split this project into multiple smaller Git repositories. So basically, you can probably see here, there's an S. So every folder here, it's actually another Git repository, which is being added here as a submodule. The reason for that was that since I would like to trigger the tasks whenever there are changes in these images. If they're in the same repo, even if you define separate tasks for the different images, every time there is a commit in the big repo, it will trigger all the images to be built. So in this case, even if I just change the README, so none of the child folders that have tasks associated to, they will still be triggered, because that's how this ACR task works. And I found that also to be quite time consuming, and well, it could get quite expensive. So then I decided to split them in repos, smaller repos, and add them here as submodules. And then whenever I do a commit in any of them, it will trigger just the task of that specific Docker image. Plus, ACR Tasks also takes care of images that depend on each other. So, for example, right now I created a task for the basic image, one for the Kubernetes one, and one for Azure. So the Azure image depends on Kubernetes, and the Kubernetes depends on basic. Each of them have a separate task. So I created here, with this command, I created one for the basic. Then here I created one for the Kubernetes one, and finally one for Azure. I also ran them manually once, so they would get an image pushed to the registry for each of them. Now, if I would make a change into the basic image, for example, and I would push it, then that would trigger a build or an ACR task running, rebuilding the basic image. When that is finished and the image is being published, ACR will detect that there was a change on the basic image, and it knows that the Kubernetes image depends on the basic. So automatically, since I created a task for the Kubernetes Docker file as well, it will trigger a build for the Kubernetes image as well, taking the latest version of the sources from the repo of the Kubernetes image. Of course, you might already predict this, as whenever this is done, whenever the Kubernetes image is done and it's being pushed, that will trigger the Azure build as well, since the Azure image depends on the Kubernetes image. And I found this pretty neat, since I wouldn't really have to care of like, what do I need to rebuild and so on. I just make my changes where I need to, I push them, and then I can trusted that it will build everything that needs to be built and nothing more. And I can show you also in Azure. So if I go to my container registry here, I have an Alex Kitty container registry, and somewhere here lower, there is a task. And maybe I should make this a bit bigger. No, this is smaller. Yeah. So here we have the 3 tasks that I have created. And I ran them a few times. You can see here all the builds, and you can access even the logs. And you can also see what type of trigger was it. Was it a commit? Was it something manual, or was it an image update? And I think this works pretty well. So let me show you how to, let me do a demo on this. So I just noticed that some of the tools I have here in the Kubernetes image, they're a bit old. So there's a new version of kubectl. There's a patch version 3. And also Go, there's also a new patch version 3. So I will just save these and go to my changes here. I'll say update kubectl and Go versions. And then I will, oh, yes, perfect. And now I can push this. Oh, I need to log in on GitHub. Let's fix that quickly. All right, so now the Kubernetes image has been updated and pushed. So we should see here, oh no, actually here on the runs, we could see here that the Kubernetes image build or task started running right now, and it was triggered by a commit. Now this will take some while, so I will pause the video until the recording until it's done and resume it there. Right, so now the build has been done, and actually you can see that the commit, the build or the task for the Kubernetes image has succeeded, and it was triggered by a commit. But then later on, the task for the Azure image has started, and it was triggered by image update. So since I updated the Kubernetes image, it triggered the update of the Azure image because it depends on it. Okay, but I'm gonna let this run, and I want to show you how I can update my local environment to use the new image for Kubernetes. So if I go here to my shell, I can show you here. I have several WSL distributions. I have Basic and also Azure and K8s. Let's connect to the K8s one and see what version of kubectl do I have. So if I run kubectl version -- client, you'll see that I'm here on version 1.18.2. And I think in the changes we have done here, I just updated it to 3. So it would be nice to use the latest version here locally. And the reason the way I've found, the way I'm doing this is through a separate profile here in the Windows terminal. So if you look at it here, you see that besides the K8s, Azure, and Basic profiles, I have 3 others which are called Update Basic, Update Kubernetes, and Update Azure. Now, these are not mapped to any any new WSL distributions. They're actually, I can show you in the settings here. For example, for Update Kubernetes, for example, it just I generated for it a random GUID. Like I used online tool called online global unique identifier generator, and this one can generate GUIDs for you. So I took one from here and I generated and added here to this profile, so it's different than the other ones. I don't know what happens if it has the same one, but I didn't even try. And then the trick is done by the command line. So here by default, if you say that the source is WSL, then Windows Terminal will use its default command for starting WSL. But if you want, you can override that and pass your own command. So what I'm doing here, I'm calling command.exe, and first of all, I make sure that I log into the Docker registry on Azure. Then I change to my user profile because that's a folder, because that's a place where I can edit stuff and where I can write stuff. By default, it goes to Windows System 32, and that is not a good idea. And then I call a Python script. So I have here a Python script that I call it with a number of parameters. It's called, the Python script is called update wsl.py. Now let me start it for the KTS one. So I'm going to choose update KTS and let it run a little bit, because it takes a bit of time to get the image and then install it locally. Yeah, so if we look in this Python file, that I have it here, it's basically a pretty simple script that expects to receive the registry as an argument, the repository, the distro that I'm trying to change or update, and then the path where it should be installed, which are basically are needed by the WSL import command that I'm using to import the tar file into the WSL. So this is pretty basic. I pull the container from my registry and repository. I create it and then I export it. After it's exported, if all goes well, I remove the existing WSL distro with the same name, and then I import the new one from the tar file. Finally, if all of this ran well, I simply start it. So it's pretty simple. So let's see how this is doing. It's still downloading, I think, the Docker image. So this is kind of slow, which is something that I would like to improve. Also, the reason for making this manual instead of having it automatically, as I would like it to be, is that since I have no way of knowing if the distribution I'm trying to update, if it's being used anywhere at this point. So ideally for me, the moment I would start a new tab of KTS, the script would be triggered and it will update it. But I would like to do that only if I'm not using that or I'm not doing anything in that distribution. And since I can't know at this point if that is happening, then I decided to go for a manual update. And there you go. The distribution has been pulled, container has been created, exported as tar, and then imported back into WSL. And you can see here, while I was running the KTS distro, it has been killed because I unregistered it and then imported back from the tar file. And now if I run here kubectl version -- client, hopefully, and actually that's what happens, I have the latest version of kubectl that I just installed in the image. Right, so yeah, So that's basically it. That's like the high level picture, and I mentioned that this is a flow that I like to use, and I think it's okay for my use. But there are a few things that I would like to change in order to be more feasible for this flow being used inside of a team. First of all, one of the things that I would like to change is that I would skip the customizations in the basic image. So I would keep this image clean of any kind of customizations attributed for a specific user. So like all of these, creating the user Alex and all of those things, I would skip this and do things in the end. Why? Because then you can have all this different tooling installed in different versions and in different Docker images, and then you would only personalize those afterwards. So whenever another developer joins the team, you could have, for example, some specific pipelines that personalize whatever development environments as the last step for that person. So that will be the first thing that I would change. Second, there's not much CI/CD things going on here. So mainly I don't have any tests and I don't use any branches and pull requests to bring changes to these images. And I think that it's very important for the situation where multiple people will collaborate on those Docker files. So basically, instead of running this ACR tasks, I would have like proper pipelines that trigger on PRs that build and run tests and then push a properly versioned Docker image to the registry if and only if the tests pass and maybe if the pull request gets approved by another developer. Yeah, the third thing, I would not use the tag latest everywhere. So I'm not sure if you noticed, but all of these Docker images, they all depend on latest. And that is okay for me, but when you're working with these environments, it's a very good idea to always know on what version of the dev environment you're running on. And also be able to track the commit that can be connected to that version of the development environment. So you always know on what versions and tools you are running on. Also, there might be situations when you want to run a specific version of a dev environment from the past, and having them versioned and pushed to the registry this way allows you to just pull an older image immediately and just use it for whatever you need. And fourth, and the last one, I would like to find ways to make the local updates faster and maybe automatic. Since right now, in order to trigger an update and use the image right away, I need to select a different option, a different profile here in Windows Terminal. I would like this to be done for me automatically and only update if I'm not using it anywhere. Also, maybe find ways to reduce the Docker image size, since they can get quite small and this, quite large, and this can make the update quite slow. All right, but this is everything I wanted to show you for now. So next, I'm planning to find ways to work on these 4 items I just mentioned and try to find solutions for them and take this proof of concept further. Of course, when I get some progress with that, I'll definitely make a video and share with you the progress. But until then, I'm curious what you think about this whole approach, and like what you like, what you don't like, whatever comes to mind. So please reach out to me in the comments or through social media. My user is Alex Kiri on Twitter and LinkedIn. That being said, thank you. See you soon. Bye-bye.